This video covers the 5-6 check for understanding. It goes with the law of sines and Heron's formula, or Heron's formula in our textbook, along with another formula that we can use to find the area of a triangle. So number one wants us to show that the law of sines is true for a 30-60 right triangle. Now, to do these correctly, what you need to do is go to the Canvas page that has the text section in it and look through the examples in the first couple of pages of the text that goes with section 5-6. So for number one, they want us to show that the law of sines is true for a 30-60 right triangle. Now, the law of sines says that the sine of an angle over its opposite side, move this up, is equal to the sine of another angle in the triangle over its opposite side, and that's equal to the sine of the third angle in the triangle over its opposite side. So given any three of these, you can use the ratio and cross multiply and find the other part. So this works for all triangles. So for number one, we need to show that the law of sines is true for a 30-60-90 triangle, a right triangle rather. So I'm going to sketch a 30-60-90 right triangle. Doesn't have to be to scale. So we got that. Now we know from our special triangle ratios that we have a 1, radical 3, 2 set of side lengths in a 30-60-90 triangle. So what we need to do is basically show that these ratios hold up. So we want to ask ourselves, is the sine of 60 over root 3 equal to the sine of 30 over its opposite side, which is the 1, and is that equal to the sine of 90 over the hypotenuse, which is 2. So that's what we need to do, is just basically show these. So if I do sine of 60 over root 3 rather, 60 sine is 0.866. Divide that by the square root of 3. I get 0.5. If I do the sine of 30, divided by 1, I get 0.5. If I do the sine of 90, divided by 2, I get 0.5. So we've shown that the sine of 60 over root 3 is equal to the sine of 30 over root 1 over 1 is equal to the sine of 90 over 2. And in all those cases, they come out to be 1/2. Let's take a look at number 3. It says, write a formula for the area of the parallelogram WXYZ in terms of A, B, and X. So here's A, here's B, here's X. Now we have another set of formulas that we need to talk about before we get started on this one. Let's look at these here. So in a triangle, after this section, we have actually 3 ways of calculating the area of a triangle. We have our traditional area is 1/2 base times height. If we have a side angle side pattern, K, which stands for area in the formula, is 1/2 AB sine theta. It's really 1/2 with a side angle side pattern, the two sides times the angle that hinges those sides together, what we call the included angle. And then the other formula that we have for area is Heron's formula, or our book calls it Hero's formula, which says that the area is equal to the square root of the semi-perimeter, which is S, and the semi-perimeter is 1/2 the perimeter of the triangle. So if you're given the three sides, you can add those up and divide by 2. That's your S. So you get the semi-perimeter times the difference of that semi-perimeter and side A, times the difference of that semi-perimeter and side B, times the difference of that semi-perimeter and side C. And you multiply those out and then take the square root, and that's another way of finding the area. For this problem that goes with number 3, notice that if we were to, since this is a parallelogram, these opposite sides are congruent to each other, and therefore opposite angles are congruent, we can actually imagine that this parallelogram is cut in half. And notice that that gives us a side angle side pattern for the WXY triangle, and that the WXY triangle is congruent to the YWZ triangle. So these two triangles are congruent to each other. So we can write the formula for this triangle using the formula where K is equal to 1/2 AB sine X. That would give us one part there. This other triangle has exactly the same area since it's a congruent triangle, so that basically cancels out the 1/2. So I'll leave that for you to finish. This other number 4 is something to think about. MNP as a unique solution. If you know M, N, and M, and basically, look at what they're saying there and think about the law of sines formula and also the area formula, and see if either Roderick is correct or if Jane is correct for disagreeing. And the important thing is here who is correct, and you need to explain why they're correct. For number 2, draw and label a triangle that has a unique solution and can be solved using the law of sines. So when they mean a unique solution, they mean that given a couple of parts, you have enough information there to use the law of sines and find all the parts, all the angles, and all the sides of the triangle. Okay, that's all for this video. This is worth 10 points. You need to show complete work here, and I got started on number 3, but I didn't finish it. It's up to you to finish it.